Hello folks, welcome to a new video. So in the last video we discussed about in brief about initializations and mutations and what difference can it make in the code or in the JavaScript that you're writing if you understand it well and if you know how it works internally. We took an example of spread operator, which is very commonly used in many use cases, and we mostly went through some cases where it might go wrong. In the next like 2 or 3 videos I wanted to cover about other array operators that we use on a daily basis. Second is the map operator, right? So whenever we need to loop through anything, or traverse through an array, most of the times we end up using for each or map operator, but I want to discuss about map operator. So what does map operator do internally? So what map operator does, let's say we have this const arr equals to array of, let's say 1 e to the power 7, 1 e7, and then we fill everything by 0. Cool. Then what we do is, let's say we want to increment every element by 1, for example, in the whole array. So let's try this. Const arr new equals to, let's say arr.map x, and we do x plus 1, and also let's do like const start time equals to performance.now, and let's do the same for con end time equals to performance.now, and let's see how long it takes. Console log time is start time minus end time array. Okay, cool. So this is the first operation, map everyone uses. So by using map, let's see what happens when you are doing this. So if I run the program, did I make some, oh, I made a typo, sorry. So let's run it again. Oh, my bad. So basically it's 382. The value is, it will be positive when we do this. Average almost, let's say 400 or something. Let's average down to that, it's close to that. So let's round it up to 400. Now what happens when you use map is, it initializes, it doesn't mutate. If you check the old array, it's still the same. It will create a new array, it will perform every operation, and it will put everything in there. So the task that we want, like finally what we wanted was, we wanted to add elements in the we wanted to add 1 to every element, right? That was our purpose of it. But what we ended up doing was, we ended up creating a new array. The old array is already there, and we filled it up with double the elements, so it's double the memory that is consumed. One is for the old one is for the new one, which is not very efficient, and for the same reason it takes a bit long, it takes this much of time. Now let's try something else. Let's try the conventional thing that we have been doing in C++. If you have started with C++, this is probably the most conventional thing that we do. For let's say I equals to 0, I less than arr.length, and we do I plus plus, and then what we can do is arr I plus plus. That's it. Basically we are incrementing it by 1. We are doing the same thing, we will have the same result thereafter. Now if we run it, it was 392. Now if we run it, it's 79. So it's crazy how fast it is, right? You were able to accomplish the same thing, that is adding one element to an array. Adding one to every element of the array, and you did it. How much x is this? Let's say 79. Let's round it up to 100 just for the sake of it. Even if it's 100, it's 4x, so it's 4 point something x faster down, right? So that's the difference mutations can make when you are when you know when to use them, right? So we accomplish the same things by 2 different processes, but in this use case we use mutations instead of the initializing thing and everything, and both of them serve our main problem statement, but we did it 4x faster here, right? So yeah, so that's one thing that I wanted to clear about map, and when to use it, when to not to use it. If you want two different arrays. Let's say you need the old array as well and you need the new array as well, and in the old array you have the old elements, in the new array you have the new elements after addition. Then it would have made sense, but for our use case we just wanted to add one to every element. So for those kind of use cases, doing a mutation or going for a mutation makes more sense because it's way faster than that, right? So this is very handy in, if you were to talk about a real life scenario, this is very handy in data manipulations and stuff. When you are sending a response from the backend, let's say you have some array, right? Instead of this stupid array I took here, let's say you have some posts object or something, you return 10 objects there, and you want to map it to some, let's say you want to you want to add some field there before sending the response. So in those use cases, if you use map, that's not efficient at all. If the number of posts is more, your time taken will be more, and imagine with concurrency, the concurrent request, that's even gonna get worse eventually. So in such use cases, understanding like mutations and using mutations might make your program a lot more efficient. In the next video, I'll discuss about splice operator, if you've heard of it. Not many people use it that much, but it's very, I like that operator very much because it's a bit tricky to understand, but it reduces a lot of overhead that we mostly do. It's hard to explain in this video. We'll see an example and I'll explain it well in the next video. So so understand when to use what and use it the way it's meant to be so that you can squeeze out the maximum performance out of it, right? So that should be it for the next video. That should be it for this video. See you in the next video. Bye guys.